Hi, everyone. Britt asked me to give you a Northeasterner's view on how observed and projected changes in climate may affect what we have to deal with in terms of drought here at the Northeast Dews. Yes, we're wet. Our annual rainfall exceeds 50 inches in many places along the coast in higher elevations. Our driest areas annually tend to be in the western parts of New York and in the Champlain Valley, where we still see between 34 or 36 inches of rainfall annually. A fair amount of our precipitation comes as snow, particularly to the north. Our annual snowfall exceeds 100 inches in many of these blue areas in the north, in the lake effect belts, in the higher elevations, and in the extreme northern parts of the region. Snow is still a fairly common occurrence, maybe not this season, but in most seasons across the metropolitan centers to our south, about 30 inches of snowfall annually in a place like New York. Our annual rainfall has been increasing since the 1950s, increasing at a rate of about an inch per decade, given by these green colors that we see across almost all counties in the region. So, since 1950, been seeing, we see about 5 to 6 inches more rainfall than we did earlier on. That's about a 10 to 15% increase. Snowpack is a different story. The number of days with at least an inch of snow on the ground has declined across the region by as much as 10 or 15 days in the extreme north at Caribou and Burlington in Vermont, and by 30 days as we move further south to Ithaca. In places like Ithaca, they tend to be on the kind of the southern border of where we see persistent winter snow cover. So I think a lot of this decline is we're seeing the winter snowpack there becoming a lot more ephemeral as time has gone on. The Northeast is diverse in terms of its population density, in terms of its uses of water. And so if we look at population density, I think it obviously stands out. Our population centers along the coast in the I-95 corridor, more than 1,400 people per square mile in Boston and New York and Philadelphia. A smattering of cities across the landscape as we move inland. But a lot of gray, so a lot of rural areas in Pennsylvania, in upstate New York, and across northern parts of New England. The bright green areas to the right indicate major agricultural areas, so a good dairy industry across New York and Pennsylvania, and also into parts of Vermont and Massachusetts. Wine grapes in the Finger Lakes of New York, can't really see them, but also on Long Island. Substantial fruit industry and vegetable industry along the Great Lakes. Cranberries in Massachusetts. So a number of different types of crops with differing demands for water. Irrigation across these primarily dairy areas of New York and Vermont is not widespread. So they rely on rain-fed agriculture primarily in the summertime. The people in the region get their water from a number of different sources. To the north, across places like Maine and Vermont, kind of a 50-50 split between groundwater and surface water, with many of these groundwater resources being small private wells, people's own wells in their own backyards. As you move further south, surface water sources, either large reservoirs serving populations of Boston or smaller reservoirs serving small communities in, say, Connecticut being the primary goal. Our big lakes and rivers provide water for a good portion of the population. And many cities also relying on smaller reservoirs with limited supply. These are likely to be the most vulnerable in a changing climate condition. What we saw from recent droughts, Worcester in Massachusetts is one of these systems, and in many cases they had to consider buying water at high prices from larger providers of water. In terms of drought, the drought monitor era has given us three, at least D3 droughts, two within the last kind of 2 years, another in 2016, which is where the Northeast dews got its start. Pretty much a dearth of droughts in through most of the 2000s, and an early drought here in 2002. We look at the longer drought record, I believe using SPI here. What we see is, again, this kind of area of not too many droughts since the 2000s. Fairly regular droughts here in through the 80s and early 90s. A lot of these affected the New York City area. A wet period in the 70s, our granddaddy benchmark drought here in the 60s, not only in terms of its magnitude, in terms of dryness, but also with the length of time. And then the earlier period of record from the 50s on through the late 1800s, a number of periods of these short-term kind of summer, maybe 1 or 2 season droughts. So really what we've seen in the recent past has not been a good guide to what we saw what we've seen in the recent past has not been a good guide to what we've seen in the distant past. Under climate change scenarios, we're expected to become wetter, particularly in winter, 20 to 30% increase in our winter precipitation. But in the summer, not so much, and actually drying 5 to 10% decreases in rainfall in Western New York and Western Pennsylvania, and only minor increases in a good part of the region. If we couple that with projected changes in temperature and that impact on potential evaporation, we see a larger evaporative demand, as much as 5 or 6 inches by mid-century and as much as 10 or 12 inches by late century. So this is really going to change our scenario for what we expect and what we look at in terms of droughts in our summertime. These changes will affect soil moisture, summer and fall soil moisture declining in the future, and actually with declines exceeding what would be expected from the natural variation, the kind of dots here. Snowpack is also going to continue to decline. Basically, what used to be a sure shot of having at least a 20 centimeter snowpack in February in Maine and northern parts of New England and New York, basically getting reduced to less than a 50% chance of seeing that much snowpack. Basically, the probability of a 20 centimeter snowpack kind of being the same as a 5 centimeter snowpack as the century moves on. These changes in snowpack affect stream flows. This is one tributary into the New York City reservoir system. So we'll see increases in stream flow in the winter compared to the historical conditions, earlier peak flows and also lower peak flows. By summer, many of the models will be showing stream flows that are below the historical mean. Again, a lot of variation here, but many models showing lower stream flows. And again, this idea of more rain versus snow showing higher flows in the winter. Our infrastructure is developed to move water from the landscape to prevent flooding. So in some cases, this pattern really, again, limits what might be available for soil moisture recharge and actually groundwater recharge. That's reflected here in these bottom sets of graphs. These are some simulations, stochastic simulations done for an area around the Finger Lakes of New York. The baseline historical conditions here, and several different scenarios of different degrees of warming, different degrees in changes in precipitation into the future. So what we see is normal peak winter snow water equivalent in March declines dramatically in these future conditions. The normal peak groundwater levels in April also decline in these future simulations. And that continues into summer, where normal summer groundwater levels fall as we move into these warmer future conditions. Again, primarily driven in this area by changes in snow water or snowpack in the wintertime. So what does this all mean? Yeah, we're going to get wetter, and we're probably wetter than most parts of the country, or we will get wetter than most parts of the country. But droughts are going to be an increasing part of the things we have to look at, particularly in summertime, as our precip increases are not as strong, and the demand for the evaporative demand during these seasons is going to increase substantially in some projections. This is going to be a big change to a number of our infrastructure systems. Agriculture in a good part of the inland Northeast is not irrigated, and we have some high-value crops, a large dairy industry that rely on that. So changes in irrigation and increased demand for water for irrigation is going to be a part of our future. Not only do we have to deal with changes in climate, but we have to deal with projected changes in land use, population, industry, even things that you might not think of in terms of drought. A big microprocessor plant is just being put in outside of Syracuse, and there's a large demand for cooling water there. That's why they selected that location as opposed to places in the drier Southwest. So these competing demands for water will be a part of our drought future. Sea level rise will affect some of our systems as the salt front affects intakes of water for cities like Poughkeepsie and Camden in New Jersey, and we'll have to really manage the flow of water on those systems to hope or try to keep the salt front further south. And then surprises, will we see another 60s drought? Projections don't suggest that, but if we do, how will these infrastructure and changes in population and industry affect these things? How will environmental concerns in water resources that are coming off of things like the Finger Lakes with changes in the landscape and potentially things like harmful algal blooms affecting water quality in these systems? So yes, drought will be a part of our future. We'll have to think about drought differently, and we'll obviously have to adapt to drought, just like so many other of the climate factors that affect our region.